right, so take a minute and read this question. And you can see that what we're talking about is we are talking about a dilation. Now, a dilation, what it does is it increases or it decreases the size of something. Okay, so it kind of shrinks it or it expands it, kind of like when you go to the eye doctor and you get your eyes dilated, the black part of your eyes look really big. Okay, so that would be a dilation. In this case, what we have is we have a line, okay, and we've got this given line right here, and they're dilating it with the scale factor of 1/2. So in other words, we're going to decrease the size of this line. We're going to cut it in half. Okay, so there's a little trick to doing a question when they're giving you a line and they want to dilate that line. So what I'm going to do is I'm going to start by just writing the equation of the line down. And I'm going to get this line in y equals mx plus b form. So I'm going to try to get the y by itself. So I'm going to add the y over. And then that's going to give me 3x equals y plus 6. And now I want to bring the 6 over because I'm trying to get that y by itself, okay? So that gives me y equals 3x minus 6. Now keep in mind that this line right here is really this line right here. I just changed the look of it and I put it in y equals mx plus b form. There's a reason why I do that. So when they're taking, now technically they're taking this line and we're dilating it by a scale factor of 1/2. The trick is all you have to do is take this line and you are going to keep your slope, which in this case is 3, and all you're going to do is you're going to take this y-intercept, which is -6, and you're going to cut it in half. And the reason why you're cutting it in half is because the scale factor is a half. If the scale factor was like a 3, we would be multiplying this by 3, okay? But because we are cutting something in half, we cut that in half. And then you can see that that's just going to give you -3. And then there's your answer, choice 4. Okay, just make sure that you're taking notes. Alrighty, the next question. So if you look at this one, we're also doing a scale factor of 1/2. So you can see that the picture, CDF, is definitely getting smaller and it's getting cut in half. Now, if you look at these two triangles, they are similar triangles. And remember, in similar triangles, the angle measures remain the same. The only thing that changes are your corresponding sides. So for example, if GH was 6, then DC would be 3 because I'm cutting it in half. If HJ was, let's say, 8, then DF would be 4 because I'm cutting it in half. But G and C, those angle measures remain the same. Same with H and D, and same with G and F. So if you look carefully at this one, okay, if you read the question, it says DFC is 40 degrees. So DFC right here, that's 40 degrees, which means HJG, that's right over here, is also 40 degrees. Those are corresponding angles, okay? Here's your answer. All right, so if you haven't already, pause me, take a minute, read this question. All right, so what they're doing is they're taking the line that you see right here and they're dilating it by a scale factor of 2. So in other words, making it twice as long. But be careful because what they're doing is they're also stating that the point of dilation is point A, which is right here. Okay, so what they're going to do is they're going to take this distance from A to B and then we're going to double it. So your new line will kind of look like that. Bad picture, sorry. Okay, when your center of dilation, which is right here, because this is what they're talking about right here, center to point A, when your center of dilation is on the line that you're dilating, what it does is it lengthens this line, okay? So it just lengthens the look of it. So really, remember, lines go on forever and ever in 2 directions. So Nathan thinks that the dilation of AB will result in the same line. He is correct, because as much as what we see right here, if you can kind of see what's under there in black, stops, it doesn't stop here because there's an arrow. So that means we can lengthen this, and it's really still the same line, okay? So what I'm going to say then is, okay, so I guess I didn't pause my video and you were just listening to me, right? Okay, so here it is. Nathan is correct because the point of dilation is on the line, and that means the dilation will result in the same line. Okay, go to the next question, pause me, and take a sec, read it, and you know what, actually, see if you can answer that question on your own. I think that you probably can, and then unpause, and then I'll have the answer for you. And there's your answer, choice 3. Okay, it can't be choice 1 and 2 because if you recall from the last question, remember angle measures, if they're corresponding angles, their angle measures will be the same. So angle TAP here will be the same as T prime, A prime, P prime. Those will be the same angle measures, so that's why these are not correct. And TA, if you look at that, that is bigger than T prime, A prime. It's double the size of T prime, A prime. Because the scale factor being 1/2, what that means then is this side, T prime, A prime, is half of that guy, which then in turn means this one is double that one. Okay, so this one wants you to look at the two triangles, and they're saying that you're basically starting with ABC, which is the big one on the left, and you're ending up with the smaller triangle, DEF. And we have a scale factor of 1/3. So DEF is 1/3 the size of ABC. Okay, so I was thinking about this one, trying to come up with a way that you could really understand rather than giving you too much information you really don't know. So I watched a video on it, and I actually like what this guy said. So this is kind of like a cheater method. All right, so for example, you could pick any 2 points, one from each of the triangles. So for example, so we're starting with the image of ABC. So this is the start guy, right? And this is the end guy. So if you look at it from this perspective, let's say I pick point B. Okay, point B or angle B would end up going to E, wouldn't it? Okay, and so, all right, hold on a minute, because I think I have another idea that I kind of want to show you that he also said, which was pretty good. So what he did was he just drew any triangle, right? So like, let's say if I draw this triangle, okay? And if that triangle is going to get dilated 1/3, which is what this exact question is saying, obviously not this triangle that I just drew, but what'll happen is here, I'm going to pick a point, and that's the point that I'm going to be dilating about. So what he said was, he's like, look, draw a line to that point from each vertice of the triangle. Boom, 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 boom. Okay? So he said then what happens is what we're trying to do is we're trying to then take this triangle, hypothetically, and I'm going to dilate it by a scale factor of 1/3. So I'm going to take this line, and I'm going to go about 1/3 of the way. So I would say like right here. And this is what I mean by that. So this distance right here is 1/3 this whole distance right here. Okay. And so then I'm going to do the same thing again, and I'm going to guess that like maybe right here is, so this distance right here is 1/3 of this whole line, okay? And again, I'm just taking a guess, just so you get the general gist of it. And then I'm going to do the same thing on that bottom line, and I'm going to say like, I don't know, maybe here. And look at what happens when you connect these. Do you see that you get a smaller triangle? It's kind of cool, right? This triangle here is smaller than this triangle here. It looks very similar, right? because they are similar, but this is a third of the size of that. And that's what you're looking for when you're doing a dilation. This is what this guy was saying. So notice where my dilation point is. It's not on one of these triangles, okay? It's off to the side. So if we go over to what we have here, so for example, 0, 0, well, 0, 0 is on one of the triangles. So that doesn't kind of give this, you know, like the megaphone, you know, when somebody screams into a megaphone, this kind of opens up like megaphone-ish like. I don't have that if my center of dilation was right here. You know, this isn't opening up, it's on this triangle. So no good. So I'm going to then just say, that's probably not going to be the answer. All right, so let's look at 2, negative 3. So I'm going to plot the point 2, negative 3. So 1, 2, 1, 2, 3, right here. Okay, well, now let's look and see what happens. So if I go like this, do you see that that kind of opens up? And then let's see, so I should have, I'm looking up here, D goes to A, right? So if this one's going to be kind of icky looking, but can you see that? And then C and F. Do you see how that does kind of megaphone out? Okay, so then what he said, which I thought was a pretty cool way of looking at it. Let me just erase what I have here. So it will be, by the way, choice 2. Okay, let me get my little marker there so you can. So it is choice 2, but here's what I liked. So he came up with the cheater method, and I love cheater methods. So what he said was, if you go, now, again, I am going to, let me just point this out to you. Okay, B is right here in the middle, and E is right here in the middle. So we know that they correspond to one another, right? Okay, so I'm going to count the distance to get from B to E. Okay, so to get from B to E, pardon me, my mistake. To get from B to 2, negative 3, that's what I meant. My apologies. So watch, I'm going to go over, what is that, 1, 2, 3, and then I'm going to go down, and you count how many down I went. Okay, so to get from B to that, I'm just going to call it X, okay? To get from B to X, what I did was I went to the right 3, and then I went down 9, right? Now, B corresponds to E, right? So do the same thing from E to the point of dilation. So I would go over 1, and then I would go down 3. Okay, so to go from E to that point of dilation, I'm going to the right 1, and then I'm going down 3. And now, if you look at everything that happened here, 3 to a 1, 9 to a 3, we divide it by 3. And that is why the answer is choice 2. Sorry, that was very long-winded. Okay, if you have any questions, when I see you, we'll go over it. Alrighty, so if you read this question, it is very similar to the very first question that we did. Okay, so if you go back and you read the first question, what we did was we had an equation of a line. In this case, we're going to find the equation of this line, okay? And then remember, when we do a dilation, the only thing that changes is the y-intercept. All right, so I'm going to find the equation of this line. So let's think about what the equation of a line is. It's y equals mx plus b, right? Okay, well, m is the slope. So I can just count. Now, you can count from A all the way over to B, or if you look here, I'm going down 1 over 1, down 1 over 1, down 1 over 1. So because my line is going down as I read from left to right, the slope will be negative, and it's going down 1 over 1, so 1 over 1 is 1. So I know that the slope is going to be negative 1x. Now, you don't have to write the negative 1, or you can. That's totally up to you. Now, remember where the B is. The B is your y-intercept. So that's where this line hits the y-axis, which is right here. So I'm going to count 1, 2, 3, 4. So this would be plus 4. So I'm just going to rewrite that because I don't like the negative 1 in there. So it's negative x plus 4. Now this is the equation of the line that you see in the graph. Now they want you to take it and dilate it with a scale factor of 1/2. So remember, when you're dilating with a scale factor of 1/2, everything stays the same except the y-intercept. So we're going to take that 4 and we're going to cut it in half. So that would be plus 2. And there's your answer.